Good day, STEM students of Sawata National High School. Today, we are going to discuss another conic section in the pre-calculus, which is the parabola. But before we are going to discuss the parabola, we have to discuss first the written work and the performance task given to you last week. Okay, so this would be the written work that was given to you last week. And then the instruction is that you are going to write true if the statement is true and write false if the statement is false. And you have to write it in capital letters. So for number 1, okay, the standard equation form of the circle is the squared quantity of x minus h minus the squared quantity of y minus k equals r squared. Now, if you notice, the operations between the squared quantity is subtraction, which is, it should be addition. In other words, this would be false. Because of that, okay, please on. Okay, number 2, if the center of the circle is at the region, we cannot use the equation the squared quantity of x minus h plus the squared quantity of y minus k equals r squared. Now take note that if the center of the circle is at the origin, therefore the coordinates is 0, 0, which has the value of h equals 0 and our k is equal to 0. If we are going to substitute these h and k to our equation, then we could have x squared plus y squared equals r squared, which is the standard equation of the circle. The center is at the origin. So in other words, still we can use the equation the squared quantity of x minus h plus the squared quantity of y minus k equals r squared, even if the center is at the origin. Therefore, this is false because we can still use the equation. Okay, number 3. The center of the circle in the equation the squared quantity x minus 2 plus y squared equals 100 is 2, 0. Now take note that since it is in the standard form, then we can identify the value of our h and the value of our k. In this case, the value of our h is equal to 2 and the value of our k is equal to 0. Therefore, the center of the circle has the coordinates of 2, 0. Therefore, this is true. Okay. The value of a in the equation 4x squared plus 4y squared minus 16y equals 0 is 4. Now, take note from our discussion last time that the general equation of the circle is ax squared plus ay squared plus dx plus ey plus f equals 0. So in other words, the value of a is the numerical coefficient of x squared and y squared. As we can see here, the numerical coefficient of x squared and y squared is 4. It is true. Okay, number 5. The center of the circle whose equation is 4x squared plus 4y squared minus 16y equals 0 is 2, 0. In this case, we are going to transform this equation into standard form. Now, let's try to rewrite that one. So you have 4x squared plus 4y squared minus 16y equals 0. As you can observe, all the numerical coefficient of the terms in the equation are divisible by 4. In other words, we can reduce the numerical coefficient by 4. So we have to divide the numerical coefficient of this equation by 4. So divided by 4, we have x squared plus y squared minus 16 divided by 4 is 4, y equals 0. Then we are going to group the terms with common variable. In this case, we don't have any other terms with x. So we have x squared plus, we have to group this one, y squared minus 4y equals 0. Now, this grouping these terms in one group, we can express this one, we can transform this one into a perfect square trinomial by completing the square, which was then discussed to you when you were in your grade 9. So you have x squared plus, we have y squared minus 4y. To make it a perfect square trinomial, we're going to get the half of the y, the numerical coefficient of y. So 1/2 of 4, 1/2 of negative 4 is negative 2, and then squared it. So negative 2 times negative 2 equals positive 4. So whatever you add in your left side would be added to your right side, so we have plus 4. So this is now a perfect square trinomial. Then we can rewrite this one into a factored form. So we have x squared plus y, the squared quantity of y minus 2 equals 4. In this case, our h is 0, our k is equal to 2, and our r would be the principal root of 4, which is 2. Therefore, the coordinates of the center of the circle would be 0, 2. Let's start to check. Here, 2, 0, which is incorrect because the center of the circle must be 0, 2. Therefore, this is false. Okay. The length of the radius of the circle whose equation is 4x squared plus 4y squared minus 16y equals 0 is equal to 4. So, since the solution here, our r should be equal to 2, which is the length of the radius. Therefore, this is false again. Here, the length of the radius of the circle whose equation x squared plus y squared equals 6x plus 2y minus 6 equals 0 is 4. So for number 7, let's try to... Okay, for number 7, we are going to rewrite the equation into standard form. So we have x squared plus y squared minus 16y. Wrong. Minus 6x plus 2y minus 6 equals 0. Okay, so in this case, we are going to group those terms with common variables. So we have x squared minus 6x would be one group, plus we have y squared plus 2y, that's one group, just minus 6. Now, take note that in our standard form of equation of the circle, there would be no constant term in our left side. So in other words, this must be, we are going to do something here to make it 0. So to make negative 6 0, we had to add here by 6. And whatever you added in the left side would be added on the right side, so we have plus 6 here. So we have x squared minus 6x, that's one group. Here y squared plus 2y, okay, equals negative 6 plus 6 is equal to 0. Then 0 plus 6 equals 6. Now these terms, these groups, okay, we are going to make this one a perfect square trinomial by completing the square. So here we have x squared minus 6x. 1/2 of negative 6 is negative 3 times negative 3, because we are going to get it squared. Then we have plus positive 9. Okay, here plus y squared plus 2y. 1/2 of 2 is 1. 1 times 1 equals 1, so plus 1 equals 6. Whatever you add here in the left side will be added to the right side. So we have plus 9 plus 1. So here, we can now express this one into a factored form. So we have x plus, not plus, minus 3 quantity squared plus, here we have the squared quantity of y plus 1 equals 6 plus 9 plus 1 equals 16. Therefore, here the h is equal to 3, our k is equal to -1, our r would be 4 because we have the principal root of 16 equals 4, and then we also have the coordinates of the center of the circle would be 3, -1. Let's try to check. The length of the radius is 4. This is true. Okay, number 8. The center of the circle with an equation x squared plus y squared minus 6x plus 2y minus 6 equals 0 is -3, 1. Here, the center is 3, 1. Therefore, this is false. Okay, now number 9. The standard equation with a circle whose general form is x squared plus y squared minus 6x plus 2y minus 6 equals 0 is the squared quantity of x plus 3 plus the squared quantity of y minus 1 equals 16. In this case, as we can see here, okay, this would be our answer. Okay, we have the squared quantity of x minus 3 plus the squared quantity of x plus 1 equals 16, which is different from what is given in the statement number 9. Therefore, this is false. And the last one, number 10. The value of c in the equation x squared plus y squared minus 6x plus 2y minus 6 equals 0 is -6. Now, take note, this is our general form of the circle. Now, as we can see here, we don't have letter C here. Okay, because it might be that the letter C or the real number C is the numerical coefficient of our x, y. And take note, we don't have x, y here. That's why the C is equal to 0. Therefore, there would be the value of C in this equation is equal to 0. So, which is false? Because it should not be equal to 6, or -6 rather. Therefore, the answers must be 1 and 2 are false, 3 and 4 true, 5, 6 is false, 7 is true, 8, 9, and 10 are false. So these are the answers for the written work. Now, let's move to your performance task. Okay, so each of you, okay, has different questions in the performance task. So some of you have these items, and some of you have no any items with this one. Okay, so for the direction, you have to identify the center and the radius of each circle, sketch the graph, state also the standard equation with a circle if it is not expressed in the standard form. In this case, for number 1, since we have this equation and it's already expressed in standard form, therefore we are not going to express this anymore because it's already in the standard form. So because it is in the standard form, we can now identify the value of our h. In this case, the value of our h is 1. The value of our k is equal to 4. And the value of our r would be 2, since this is 4. So the positive square root or the principal root of 4 is 2. And of course, we can now get the coordinates of our center, which is 1, 4. Okay, so in this case, let's try to graph. Okay, let's try to graph. The center is at 1, 4. So 1, 4 here. So this is the center. And we have the radius of 2. So 1, 2. So it passes here, that point. 1, 2, 1, 2. And 1, 2. Okay, so this would be the circle. Okay, now let's try to check if this solution would be correct. Okay, now let's have the answer key. So here is the answer key. Okay, as we can see here, the center is 1, 4, which is correct. The radius is 2, correct. And as you can see here, it passes through the points that I had made mention. So you have this point, this point, this point, and this point. Therefore, our graph is correct. Now let's have item number 2. For item number 2, as we can see here, it's not expressed in the standard form. Therefore, we are going to express that one into the standard form. Okay, so remember that the standard form is ax squared plus ay squared plus dx plus ey plus f equals 0. Okay, so let's have the x squared. So we have the x squared. X squared plus y squared. This one. It should be, after this one, it must be x. So since our x is written on the right side, then we have to add both sides for x. So this would be 4x. So negative 4x plus 4x equals 0. Okay, now we have the y. In this case, since the y is written on the right side, then again, we have to add both sides, negative 2y. So here we have minus 2y. Okay, then minus 4 equals 0. So this equation can be written like that. Okay, now let's transform this one into standard form. To transform this one into standard form, we have to group the terms with common variables. So we have x squared plus 4x would be grouped as and then plus another group y squared minus 2y minus 4 equals 0. Now remember that on the left side of the equation, in the standard form of equation of the circle, there would be no constant term. So there would be no constant term here. Therefore, we have to make this negative 4 0. To make this one 0, we have to add 4. Okay, and then whatever you added in the left side would be added to the right side. Okay, plus 4. So here we have x squared plus 4x. This is one group. Plus y squared minus 2y. Again, another group. This is equal to 4 because 0 plus 4 equals 4. Negative 4 plus 4 equals 0. Now these groups, okay, we are going to make this one a perfect square trinomial by completing the square. So remember, that is then discussed to you when you were in your grade 9. Okay, so you have x squared plus 4x. Okay, 1/2 of 4 is 2 and 2 times 2 is 4. So you have plus 4. Remember, whatever you added on the right side would be added to the left side. Okay, plus you have y squared minus 2y. 1/2 of negative 2 is negative 1. And negative 1 plus negative 1 equals 1. So plus 1. So plus 1 here. So here you can have, we can now rewrite this one into factored form. So you have x plus 2 quantity squared plus the squared quantity of y minus 1 equals 4 plus 4 plus 1 equals 9. Therefore, our h would be negative 2, our k is positive 1, the radius is 3, and the coordinates of the circle center is negative 2, 1. Okay, so we can now graph this one. Okay, so the center is at negative 2, 1. So negative 2, positive 1. So this is the center. And then the radius is 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Okay, so form a circle passing through those points that I had made mention. Okay. And this would be the graph of the circle. Okay, let's start to check whether this would be the correct answer or not. Okay, as you can see here, the center is negative 2, 1. That's correct. The radius is 3, correct. And it passes through the points that I have made mention. Therefore, this is the correct answer. Okay, let's have another item. So this would be the item number 2. So as we can see here, it's not expressed in the standard form. Okay, so let's transform the equation into the general form of equation. So let's have x squared plus y squared. Here we have the 8x is on the right side, so that becomes negative 8x. Okay, minus 2y plus 8 equals 0. So here we are going to group those terms with common variables. So you have x squared minus 8x, that's one group, plus y squared minus 2y, that's one group, plus 8 equals 0. But in this case, we have to see to it that the left side should have no constant term. So minus 8. Minus 8 on the right side. So we have the quantity of x squared minus 8x plus the quantity of y squared minus 2y equals negative 8. So here, those quantities, we can express this one into a perfect square trinomial. So you have x squared minus 8x. So 1/2 of negative 8 is negative 4, and negative 4 times negative 4 equals positive 16. Plus, here we have y squared minus 2y. 1/2 of negative 1, negative 2 rather, is negative 1. And negative 1 plus times negative 1 is positive 1. Whatever you added on the left side would be added to the right side. So you have negative 8 plus 16 plus 1. Okay, now here we can express this one into its factored form. So we have the squared quantity of x minus 4 plus the squared quantity of y minus 1 equals negative 8 plus 16 plus 1 is equal to 9. Therefore, our h must be 4, our k would be 1, the radius is 3, and the coordinates of the circle, coordinates of the center would be 4, 1. So let's start to check. Okay, the center is 4, 1, correct? The radius is 3, correct. So let's try to graph this one. Okay, I forget to graph. So you have 4, positive 1, so this is the center. Passes, the radius is 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So that would be the points on the circle. So let's create a circle. Okay. Okay. So if we are going to compare that one, compare the graph. Okay. They are on the same points. Okay. So let's have number 4. Okay. Again, as we can see here, it's not expressed in standard form. So we have x squared plus y squared, because here we have to add both sides y squared, minus 4x, then minus 6y plus 9 equals 0. So we have to group those terms with common variables. So you have we have the quantity of x squared minus 4x plus another quantity of y squared minus 6y, that's one quantity, plus 9 equals 0. But take note, there should be no constant term on the left side, so we have to add negative 9 to both sides. So here we have this term, okay, this root must be expressed into perfect square trinomial by completing the square. So you have x squared minus 4x. 1/2 of negative 4 is negative 2. Negative 2 times negative 2 equals positive 4. Therefore, plus 4. Again, whatever you add on the left side would be added to the right side. Plus 4. Plus, here we have y squared minus 6y. Okay, 1/2 negative 6 is negative 3. Negative 3 plus times negative 3 equals positive 9. So here, plus 9. Therefore, we have, completing the square, we have x. We have to write this one into its factored form. So we have the squared quantity of x minus 2 plus the squared quantity of y minus 3 equals negative 9 plus 4 plus 9 equals 4. Okay, so we can have the value of our h is 2, the value of our k is 3, the value of our r would be 2 since it would be the positive square root or the principal root of 4, and of course the coordinates of our center would be 2, 3. Now let's start to graph this one. Okay, the center is 2, 3, so 2, 3, and then the radius is 2, 1, 2, 1, 2, 1, 2, 1, 2. And then make a circle passing through those 4 points. Okay. Now let's try to compare if this is the correct one. Let's try to compare to the answer key. Okay, the center 2, 3, radius is 2. Okay, they have similar graph and these are the correct answers. So quite easy, right? So I hope you got a perfect score in our performance task and written work. So let's move on to our main discussion for this day, which is the parabola. Okay, for our parabola, for this discussion, let's have the objectives. So at the end of this discussion, you may be able to define the parabola and of course graph the parabola given the vertex form or given in vertex form. Now in our previous discussion last week, we have already discussed or defined the conic section. Now, let's start to define the conic section in terms of its in analytic geometry. Okay, or we have to define the conic section in analytic geometry. So a conic section is defined as the path of the points which moves so that its distance from the fixed point, called focus, is in the constant ratio to its distance from a fixed line called directrix. The constant ratio is called eccentricity with the representation of letter E. As we can see here, we have very technical terms. The technical terms here is we have we have the focus. This is very technical one. We have the directrix, and we have eccentricity. Now, for visualization of this focus, the directrix, and eccentricity, when we say focus, it's a fixed line. So as we can see, fixed point rather. As we can see here, the point focus is not moved. Okay, and then the directrix is the fixed line, therefore it also not moves. And then the eccentricity is actually the ratio of this line over that line, and that's what we call as eccentricity. Now, if the eccentricity is less than 1, as we can see here, okay, the distance of this point of this line over this one is less than 1. So if the eccentricity is less than 1, then this is ellipse. If the eccentricity is equal to 1, therefore this line and this line are equal. Okay, so it is parabola. If the eccentricity is greater than 1, so E is equal to 1, not equal to 1. It should be greater than 1, then it is hyperbola. Now, what is the eccentricity of a circle? Okay, the eccentricity of a circle is actually approaches to 0. Okay, it's a special case. Circle is a special case of the conic section. So the E will be approaches to 0. So it could be positive number or negative number as long as it approaches to 0. And if the E eccentricity is equal to 0, then that case the definition of eccentricity and the conic section fails. So that's it. Now, let's move. When we say parabola, the parabola is a conic section whose eccentricity is equal to 1. That's what I have mentioned in the previous slide. This implies that it is the locus of points which are equidistant from the fixed point and a fixed line. So when we say locus of points, these are the points on the graph. Okay, so if you can still remember, parabola was then introduced to you when you were in your grade 9. But the definition of the parabola or the presentation of the parabola in your grade 9 would be somewhat different from what we are going to discuss here. But they have the same concept. Okay, now to visualize the parabola with this eccentricity, the locus of points, the fixed point, and the fixed line, we have this one. When you were in your grade 9, focus, directrix, and axis of symmetry, I guess axis of symmetry is included in your grade 9. Focus, the directrix was not given to you when you were in your grade 9. Okay, as we can see here, if the distance from the focus to any point on the circle is equal to that point to the directrix are equal, then it is a parabola. Therefore, okay, here, this line is equal to that line. Okay, now let's have some parts of the parabola. Now, when we say axis of symmetry is actually the line that divides the graph into two equal halves, thereby creating a mirror-like reflection of either side of the graph. it passes through the focus and perpendicular to the directrix. Now, in this case, the broken line in red is our axis of symmetry. Now, if we are going to fold the graph along the axis of symmetry or along the broken line, okay, we can imagine that this portion of the graph is would be touched the other side. So they are symmetry. So that's what we call as axis of symmetry. Now, when we say focus of the parabola is a fixed point on the interior of the parabola using the formal definition of the curve. So the definition of the conic sections always involves the fixed point called the focus. In this case, the focus is this one. Okay. Next, when we say directrix, it is a fixed line perpendicular to the axis of symmetry. The distance of this line to the vertex is equal to the distance of the vertex to the focus. Now, what does it mean? Now, this blue broken line is our directrix. Okay, the distance of the directrix going to the vertex, okay, this distance, and the distance of the vertex going to the focus, they are the same. If this is A, then this is also A. Okay. And always remember that when we say directrix is always perpendicular to our axis of symmetry. Now, let's have vertex. Okay, I guess vertex is then given to you when you were in your grade 9. So just to refresh, to recall, the vertex is a point at which the graph turns. So since the parabola turns once, then it has one vertex. And in this case, the vertex is this point. Okay, it's the turning point of the parabola. Okay, the lattice rectum is the line segment whose endpoints are points on the graph and passes through the focus. The length of the lattice rectum is 4 times the distance of the vertex to the focus. Now, when we say lattice rectum, it is the line segment passes through the focus. So it should passes through the focus. And then, okay, endpoints are on the graph or in the parabola. And by definition, this line segment is 4 times of the segments. If this is A, then this is 4A. Okay, so these are the common parts of the parabola. So this time, let's state the standard equation of the parabola. Okay, now let's say we have a point P on the parabola. So let's say this is our point P. Okay, the point P. And the coordinates of point P is x, y. So let's have this one. Now, by definition, okay, the distance of that line, of the distance of these 2 points, and if we are going to make a perpendicular line here, okay, so let's say that is S. Let's say this is point S. Okay, take note that these 2 lines are congruent with each other by definition of the parabola. Now, let's say that this point, okay, let's say the focus, let's say F, okay, the focus has the coordinates of we have here 0, A. Why 0A? Let's assume that the vertex is at the origin. Okay, The vertex is at the origin. And take note that, let's say this distance is A. Therefore, the coordinates of the point F, the focus, is at 0, A. Okay, therefore, this is also A. Therefore, the coordinates of this point S is equal to, you have X negative A. Okay, now with this information, now we could say, by definition, we could say that the line segment SP is equal to the line segment of PF. Okay, so these two line segments are equal because the eccentricity is equal to 1. Now, take note that SP, okay, SP, the distance is, we have from this vertex going to this point is equal to A. And then from here going to that one, that's Y. Therefore, the distance or the length of SP is equal to A plus Y. So as I said, since this is A, right? These are perpendicular lines. Okay, so this is A. Okay, from the vertex going to this point. Okay, so in other words, this one to this one is A. And of course, from this point going to this point, that's Y. So that's why we have the line segment SP is equal to A plus Y. Now, is equal to this point going to this point. Using the concept of the distance formula. So, distance formula was then discussed to you when you were in your grade 9. Okay, the square root of, okay, this point going to this point. So, you have the x. Okay, x, and then we have 0. Okay, minus 0 quantity squared plus y. Y plus a minus a. Minus a quantity squared. Okay, so we have that formula. We have that equation. Now, since on the left side, or in the right side rather, we have the square root. Okay, take note when you were in your grade 9 that if the quantity is a square root, the square root is equivalent to exponent 1/2. So, if we are going to rewrite this one into exponential form, then we have a plus y is equal to the quantity, we have another squared quantity of x minus 0 squared plus the squared quantity of y minus a, and then raised to 1/2. Now, to get rid of 1/2, we have to find a number that if we will multiply that 1 to 1/2, the answer is 1 because it's the exponent. So, we have to multiply, and not multiply, raise both sides by 2. Okay, raise both sides by 2. So, 1/2 times 2 is equal to 1. Therefore, you have a squared quantity of a plus y equals, you have, of course, x minus 0 is equal to x, so you have x squared plus, we have the squared quantity of y minus a. So that one. Okay, so this would be 1. This is 1. Now, as you can see here, okay, we have on the left side, e has a power of 2, and on the right side has a power of 2. Now, let's try to expand this one. So, to expand the left side, then you have a squared. Okay, a squared. Now, for the middle term, you have 2 times y times a. So, you have 2 up sorry, there should be an operation here. Okay, let's try to delete first. Okay, so we have plus 2ay plus y squared. Y squared equals, we have x squared plus, here we have to expand this one, so y squared, so since it is minus here, then we have minus 2 times a times y, so 2ay plus a squared. Now in this case, on the right side and on the left side, they have the same quantity. So what are those the same quantity? So we have a squared. So a squared would be, okay, cancelled out. And then y squared would be cancelled out because they are the same in both sides, left side, right side. So what remains is that we have 2ay, okay, 2ay equals x squared minus 2ay. Now, if we will if we are going to transfer the negative 2ay on the left side, okay, so we have, if we are going to add 2ay here plus 2ay, so what will happen is we have 4ay equals x squared, or we can have x squared equals 4ay, and this would be the equation of this parabola. Okay, so if the vertex is at the origin and it is open upward, then we can express the equation with circle as x squared equals 4ay. Now, what will happen if it is expressed on the, if the graph is open downward? Then we could have x squared minus, x squared equals negative 4ay. So let's have this one. Okay, now, if, okay, focus on this portion. Okay, if the parabola is open to the right, if it is open to the right, then we have y squared equals 4px. Okay, if it is open to the right. Now, if it is open to the left, then we have y squared equals negative 4px. It is open upward, this is what we have get in the previous slide, then you have x squared equals 4py. Okay, and then if our equation, if the graph is open downward, it is x squared equals negative 4py. Okay, if you are confused why we have p here, because in the presentation here, in this slide, okay, the distance from the vertex going to the focus is p. That's the presentation here. Okay, this is p. This is p. That's why we have p here. But do not be confused. If the vertex is expressed in a, or if the distance between the vertex going to the focus is a, then this would be a. So we are just going to substitute the p with a. Okay. Now, that is if the vertex is at the origin. Now, what will happen if the vertex is not on the origin? Okay. Now, if the vertex is not on the origin, okay, we are just going to deduct the h and k. So here, equation 5, if the graph of the parabola is open to the right, then we have the squared quantity of y minus k equals 4p times the quantity x minus h. Okay. If open to the left and the vertex is not on the origin, then we have the squared quantity of y minus k equals negative 4p times the quantity x minus h. And if it is open upward, okay, with the vertex not on the origin, then we have the squared quantity of x minus h equals 4p times the quantity of y minus k. And lastly, if it is open downward, then we have the squared quantity of x minus h equals negative 4p times the quantity y minus k. So, in other words, we have 8 formulas or 8 equations of parabola. Whether it is open upward, open downward, open to the left, open to the right, and the vertex is not on the origin. And of course, the vertex is in the region. Okay, so let's have some examples. Okay, before I forgot, by the way, this 4p, okay, this 4p is actually the length of the latus rectum. Okay, remember the definition of the latus rectum? The length of the latus rectum is 4 times the length of the segment joining the vertex to the focus. Okay, so the 4p there is the length of the latus rectum. Now, if you want to determine the length of the segment joining the vertex and the focus, then you have to divide both. You have to divide the 4p by 4. Okay, so let's have the example. Determine the coordinates of the vertex, axis of symmetry, focal distance, length of the latus rectum, and endpoints of the latus rectum of the parabola x squared equals negative 4y. And then you have to sketch the graph. Now take note that if we can see here, if we can notice, okay, so x squared equals negative 4y. In this case, the vertex is at the origin. So the vertex is at the origin. Therefore, clearly, the vertex is at the origin. Okay, now, since you have negative 4y, therefore, it's open downward. Open downward. And then, as you can see here, as what I have made mention, that 4p is the length of the latus rectum. Therefore, okay, the length of the latus rectum is equal to 4. Therefore, the distance of the vertex going to the focus is equal to 1. So the distance of the focus, let's say that's A, is equal to 1. So in other words, this would be the focus. So in other words, the focus has the coordinates of 0, 1. Okay. And then, since the length of latus rectum is 4, then from the focus, we can count 2 units to the left and 2 units to the right. So 2 units to the left, 1, 2, and to the right, 1, 2. Therefore, the graph of the line passes through these points. Okay, so in other words, let's sketch the graph. Okay, something like this. Okay, of course, the axis of symmetry is this one. Okay, this is the axis of symmetry. As you can see here, okay, the axis of symmetry is x equals, not x, but y. So y equals 0 because the axis of what we call this one, it is open downward, and then the vertex is at the origin. Now, if this would be the focus, therefore the directrix is here. This would be the directrix. This would be the Directrix. Though it's not in the instruction, let's say the Directrix is equal to uh, so the Directrix has an equation of x equals 1. Okay, although it's not mentioned in the example or in the problem to be solved, but for emphasis, the Directrix has an equation of x equals 1. Now let's try to check whether our answer is correct. So this would okay, so this would be the curve of the parabola. So as you can see here, the vertex is at the origin, which is just the same with that one, and then passes to this point and to this point. So this point is 2, -1. Here we have -2, -1. So we have the same points here? Yes. Therefore, that's the correct answer. Let's have another example. Determine the vertex, the axis of symmetry, the focus, the focal distance, length of the endpoints, and length and the endpoints of the lattice rectum of the parabola y squared equals 12x. Then graph the parabola. As we can see here, okay, we can have the parabola is y squared equals -12x. So since it's y squared, okay, the vertex, clearly here, the vertex is at the origin, 0, 0. So here's the vertex. And since it's y squared, then it opens to the right. Opens to the right. And then we have 12. So in other words, our lattice rectum, the length of the lattice rectum, let's say L, is equal to 12. Therefore, the length of our focal, the line segment joining the vertex and the focal point is equal to, so 12 divided by 4 is equal to 3. Okay, so open to the right. So here, so 1, 2, 3, this would be our focus. So this would be our focus. Now, since the length of lattice rectum is equal to 12 divided by 2, then we have 6. So 1, 2, 3, 4, 5, 6. So here, and then 1, 2, 3, 4, 5, 6 here. Okay. Now, therefore, the endpoints of the lattice rectum, okay, so the endpoints, so that's why, let's say this is L1. Okay, our L1 has the coordinates of, we have 3, 6, and let's say this is L2. Then we have our L2, the length, the endpoints of the lattice rectum, okay, is equal to, we have 3, -6. And then sketch the graph. By the way, as we can see here, the axis of symmetry is this line. Okay, passes through the center, the focal point, and the vertex. So that line is our axis of symmetry. So the axis of symmetry here, we have x equals 0. And the Directrix, as we can see here, our Directrix has an equation of, okay, since this would be equal to 3, and the distance between focus and the vertex are equal to the distance of the vertex to the Directrix, therefore it passes here. So this would be our Directrix. So this is x, not x equals 3. By the way, the focal, the axis of symmetry must be y equals 0. I forgot. Okay, let me check first. Let me correct. Okay, this must be y. Okay, this must be y. And this would be x equals 3. Okay, and then sketch the graph. Oh. Okay. So from this point, going to this point. So let's try to connect. Somewhat like this one. So that would be our graph. So let's try to check. Okay, the vertex is at the origin, correct? And then it passes through the point. We have the lattice rectum, end of lattice rectum. We have 3, 6, and 3, -6. Therefore, it's correct. I guess I have something wrong with my answer in example number 1. So let's review. Okay, the directrix must be y equals 1. Here, let me correct my answer here. Sorry guys. Here, it must be y equals 1. And our axis of symmetry here, the axis of symmetry here must be x equals 0. I mistakenly interchanged those two variables. Okay. Okay. Let's have example number 3. Determine the vertex, the axis of symmetry, the focal distance, let's say A, the focus, the length, and the endpoints of the lattice rectum of the parabola y squared equals -1/2 x. Graph the parabola. In this case, as we can see here, the parabola is at the vertex of the parabola is at the center because of the format of the equation. So here we have the vertex is at the parabola. So clear, we have here the parabola, the vertex rather. And then the length of the lattice rectum is 1/2. This one. Therefore, if the length of the lattice rectum is equal to 1/2 or 0.5, then we can clearly say that the length of the line segment joining the vertex and the focal point is just divided by 4 of 1/2. Okay, 1/2 divided by 4 is equal to 1/8. Okay. Then, since it's -1/2 x, it's open to the left. Okay. So 1/8 is equal to 1/8 is equal to approximate that is 0.125, right? So approximately 1.3 because we don't have 125 here in our points. So this is 1 and this is 1. This is 0.15, therefore somewhere here. So somewhere here is our focus. So somewhere here is our focus. Now, the end of the latus rectum is 1/2 of the latus rectum. So 1/2 of 1/2 is 1/4. So that's 1.25. So 0.25, so it should pass here, and it should pass 125 passes here. Somewhere that one. And then, so in other words, our L1 must have the coordinates of, you have negative 1/8. Negative 1/8, because it's open to the left. Then 1/4. And the second endpoints of the latus rectum must be negative 1/8, negative 1/4. Okay. And then what else? Okay. So connect the points. So something like this. Okay, something like this. Let's try to check. Does we have, okay, correct. We have this one, the vertex. And then it passes to somewhere here. Are we just the same? Okay. Okay, so we have the correct graph. Therefore, we also have the correct axis of symmetry. By the way, the axis of symmetry here is this one. This would be the axis of symmetry. So, the axis of symmetry, we have y equals 0. And of course, our directrix, we have x rather. Why I have to write y? It should be x. So it should be, okay, x is equal to, we have 1/8. Okay. Okay, so let's have example number 4. Okay, for number 4, determine the vertex, the focus, the focal length of lattice rectum, and points of the lattice rectum and the axis of symmetry of the parabola. Okay, and then graph the parabola. In this case, as we can see here, that the equation is this one. Therefore, we can now identify the h and the k. So remember that the partner of x is our h and the partner of y is our k. So in other words, our h would be 4, our k is equal to 1. Therefore, the vertex must be 4, 1. Okay, so we have now the vertex. The vertex must be 4, 1. 4, 1. So that's our vertex. Now take note that it is y, the squared quantity of y minus 1, okay, equals 8. So in other words, it is open to the right. So our length of the latus rectum, okay, so this would be the length of the latus rectum. The length of the latus rectum is equal to 8. Therefore, the focal length, the focal distance, is equal to, divided by 4, 8 divided by 4 is equal to 2. So in other words, since it's open to the right, then we can now count 2 units from the vertex. So that's 1, 2. So this is our focus. Okay. The focus must be at 6, 1. Okay. Now, the focus is a 6, 1. Then the focal distance is 2. Yes, we have Then the length of the latus rectum, we have 8. The endpoints, okay, since it is the length of the latus rectum is 8, then if we are going to divide 8 by 2, then we can get the end of the latus rectum. So we have 8 divided by 2 is equal to 4. So 1, 2, 3, 4. And 1, 2, 3, 4. Let's say this is our L2 and this is our L1. Therefore, L1 has the coordinates of 6, 5. 6, 5. And our L2 is equal to, has the coordinates of 6, 3. 6, negative 3 rather. Okay. Now, then we have, of course, the axis of symmetry that passes through the focus and the vertex. So this one. This line. So we have our axis of symmetry is equal to y equals 1. And of course, since the distance of the focus to the vertex is equal to the distance of the vertex going to the directrix, then this would be our directrix. Assuming that it's a straight line. So our directrix has an equation of x equals 2. Now let's try to connect the points. So something like this one. Okay. So this would be the graph. Let's try to check. Okay, here clearly the focus, the vertex is this point rather. So we have 4, negative 1, that's correct. And it should pass the point 6, 5. So 6, 5, correct. And 6, negative 3, correct. So we have the answer for number 4. Example number 5. For example number 5, we have here again the vertex, the focal distance, focus, length of latus rectum, endpoints of the latus rectum, and the axis of symmetry of the parabola. So here, as we can see here, we have again, we can identify the vertex here. The partner of x is our h. So h is equal to negative 4. Our k is equal to 3. That means, that implies that the vertex is equal to negative 4, 3. So here we have negative 4, positive 3. This is our vertex. Now, so you can see here, since it is minus 12 or negative 12, it opens to the left side. So the length of the latus rectum is equal to 12. Therefore, the focal distance, let's say A, is 12 divided by 4. So 12 divided by 4 is 3. Okay, so in other words, we can now identify the focus. The focus here is equal to, okay, 1, 2, 3, just count 3 points or 3 units. So that is negative 7, 3. 7, 3. And of course, this would be our axis of symmetry. So for the axis of symmetry, we have y equals 3. Okay, and then end of the latus rectum. For the end of the latus rectum, let's say we have to divide 12 by 2. So 12 divided by 2 equals, yes, that's 6. So from the focus, let's count 6 units upward. 1, 2, 3, 4, 5, 6. And then from the focus, counting 6 units downward. So 1, 2, 3, 4, 5, 6 at that point. Therefore, let's say this is our L1 and this is our L2, end of the latus rectum. So L1 has the coordinates of, what's that? Negative 7, 9. And L2 has the coordinates of -7, -3. And since this is 3 units, we are going to count 3 units here. 1, 2, 3 to determine the equation of the directrix. So the directrix has an equation of x equals -1. So let's try to connect those points. Something like this one. Okay, let's try to compare. Okay, the vertex is at -4, 3, -4, 3. We have -4, 3. Okay, that's correct. And then it should pass to the point -7, 9. -7, +9. That's correct. And then we have -7 past -3. So in other words, our sketching the graph is correct with the correct information given. Okay, let's have the last example. Write the equation of the parabola with a vertical axis of symmetry. Vertex at the point 5, 1 passing to the point 1, 3. Now take note that since it is vertical axis of symmetry, so dahil pa tayo. Okay, so if the it's either open upward, open downward, right? So we have y squared here, there. X squared rather, x squared. Now, the vertex is at 5, 1. So the vertex is at 5, 1. So this is the vertex. Okay. So in other words, the h is equal to 5. The k is equal to 1. And we have the point, k, 1, 3. So the point is our x is equal to 1, our y is equal to 3. Now, let's just going to choose whether it's open upward or open downward. Now, in this case, we're going to use the concept of here. We have x minus h squared is equal to 4a times the quantity of y minus k. One. Let's say it's open upward. Okay. So here we have substitute the value of h and x. So we have 1 minus 5. Oops. Oopsie. Oh my. Okay, so we have to substitute the value of our x. We have 1. Then substitute the value of our h minus 5. Quantity squared is equal to 4a times the quantity of, substitute the value of our y, which is 3, minus 1, our k. So here we have 1 minus 5 is equal to -4 squared is equal to 4a times 3 minus 1 is 2. So -4 squared is equal to 16 is equal to 4 times 2 is 8. So if we divide both sides by 8 here, then our a must be what? 2. In other words, the length of the lattice rectum is 2. And not the length of the lattice rectum, the length of the focal length of the segment from the focus going to the vertex is 2. So if the vertex is at 5, 1, so 5, 1, Then we have two scenarios here. The first scenario is if it is open upward. Okay, then we have 2 points. Okay, it could be here or it could be here. But take note that the graph passing through the points 1, 3. So 1, 3. So here. So since the graph is this one, okay, and of course this would be the vertex, the turning point, we have no other way but to open upward. We cannot go open downward, right? Because if this open downward, something like this one, okay, if we are going to open downward here, let's say that one, it will not pass to this point. Okay, so it's open upward. So since it is open upward, so our focus must be this one, open upward. So our focus would be, okay, our focus must be, what is the one? 5, 3. 5, 3. So the focus is 5, 3. And then the length of the lattice rectum is 16. Is 16. Half of 16 is 8. Wrong. If a is equal to 2, then 4a is equal to 4 times 2, which is equal to 8. Therefore, our length of the lattice rectum must be 8. So, this must be 8. This must be 8. Therefore, because it is 8, then we could have 8 divided by 2 is 4. So here from the focus, let's have 4 units to the left and to the right. So 1, 2, 3, 4 and 1, 2, 3, 4. And therefore, let's say this is our L1 and this is our L2. So our L1 has the coordinates of 1, 3, and our L2 has the coordinates of 9, 3. Okay, so write the equation of the parabola. In this case, we could have the equation, okay, so the equation must be, you have x minus 5 quantity squared equals length of the lattice rectum is 8 times y minus 1. Okay, so that would be, this would be the equation of the parabola. So let's try to check. I forgot to connect the points. Okay, something like this one. So I hope you got something with my discussion. So I guess that's all. Salamat sa panunood. Thank you and happy answering your modules.